In today's video, we're going to wrap up our conversation about operant conditioning, and then we're going to move on to talk about social learning, last of our four categories of learning for this chapter. So we had left off, we had just finished talking about punishment and why it isn't necessarily the best or most desirable form of getting a particular behavior to occur or even to not occur. And now we're going to move on to talking about two sort of related concepts, and these concepts are shaping and chaining. So far, when we've been talking about these actions that we're having organisms do, things like pushing a button or pulling a lever or pecking a screen, these aren't necessarily activities or actions or behaviors that would be normally occurring in an organism's repertoire. These aren't things that a rat or a pigeon do naturally. So how do we actually get them to do these particular behaviors? And the answer to that is the first of our concepts, and this is shaping. So the process of shaping involves reinforcing successive approximations towards a final desirable response. So if we're trying to get a rat to press a lever, then maybe we want to start by our first approximation is we'll reinforce the rat if they're facing the lever. So if they're in an operant box and they face in the direction where the lever is, we're going to give them food. Once they're reliably facing the lever, we're going to stop reinforcing that stage and we're going to only reinforce them when they start approaching the lever. That would be our next approximation that we would reinforce. So we'd give them food for approaching the lever now, but not just for facing it. And then once they're reliably approaching the lever, then you'd only give them food when they actually touch it. So no longer just approaching it, they have to physically touch it. And then once they're doing that reliably, we would only give them food if they actually push the lever, and none of those earlier approximations would get reinforced. So through this, we use that successive approximations, the reinforcement of successive approximations, towards our final response of lever pushing, and we specifically no longer reinforce previous approximations. So once they're doing something reliably, we stop reinforcing it and move on to the next approximation. So this would be an idea of, say, differential reinforcement, where we're reinforcing some actions but not others, and we're using it to shape their behavior, to get them to do that desired behavior that we want them to be doing, which is pressing a lever. Our next concept here is the concept of chaining. And this is when you start stringing together or chaining together a series of responses. So instead of just getting an organism to produce a single action or a single behavior, we want to get them to do multiple behaviors, multiple responses in a row. And to do this, we would reinforce each response in that chain with the opportunity to perform the next response. So you see this a lot in, say, training pets. And there's lots of really neat rat training videos if you go looking on YouTube. But there's one where there's a rat and it's moving a ladder. So the rat has to lift a ladder from the floor up to a platform, and then from that first platform up to a second platform, and then from the second platform to a third, and then from the third they use the ladder to get across a gap to obtain food. So this would be a great example of chaining because we have those distinct individual steps of getting the ladder to the first platform, the second, the third, and then across the gap. But there's no reinforcement provided at each of those steps. The rat doesn't get food just for getting to that first platform. Instead, by getting to the first platform, that's the first step that allows them to then perform the second step, that then lets them perform the third, that eventually gets them to the food. If they don't do the first step, then they don't have the opportunity to get the food at the end. So chaining has sort of indirect reinforcement because each step along the way is not primarily reinforced with food, but it does give them the chance to work towards getting the food at the end. So this is a way of developing a sort of complex sequence of behaviors by stringing simpler responses together one after another. Next, we're going to be talking about extinction, but specifically operant extinction. We had already talked about extinction as it applied to classical conditioning. So for classical conditioning, extinction was when we would present our conditional stimulus repeatedly in the absence of our unconditional stimulus. So you would ring the bell without giving the dog food. And then eventually their salivation response, that conditional response, would start decreasing to that conditional stimulus because it's no longer associated with the original unconditional stimulus. So that was your classical conditioning extinction. And for operant conditioning, extinction is going to be fairly similar, where instead of looking at the decrease of that conditional response, now we're going to look at the disappearance of our operant response. So our definition here is that extinction is the weakening and eventual disappearance of a response, an operant response, because it is no longer followed by the consequences that it used to be followed by. So if a rat was pressing a lever to get food and then pressing that lever no longer got them food, they're probably going to end up pushing that lever less overall. However, because this is an action that the rat is taking, it's an operant response, it's something, behavior that they're choosing to do, we're going to see a couple of differences here. So instead of during our classical conditioning where we saw a pretty swift drop-off in that salivatory response, a pretty quick drop-off in our conditional response during extinction, we have some extra stuff to watch out for with operant extinction. The first of these is called an extinction burst, and this is a temporary increase in responding. And this is usually accompanied with either emotional and or aggressive responding. So if a rat's been pressing a lever to get food for a really long time, and then all of a sudden pressing that lever doesn't get them food, they're going to press the lever more quickly, more aggressively, in the hopes of getting food from it again. But when that doesn't work, when that sort of angry outburst doesn't help, they will eventually stop responding. And so if we wanted to look at a diagram, kind of like what we saw when we were looking at our classical conditioning, we can look at this one here. We have time on the bottom here. This time it's listed as days instead of trials like we've seen previously. And then on this axis, this would be our response frequency. So this is just from an example where someone was text messaging a friend. So during this process, during the normal reinforcement stage, when we have our reinforcement delivered, so if a friend sent a text message, they would get a response fairly quickly. And then if we move into extinction, sending a text message no longer gets a response. So the individual would have an extinction burst where they would send more text messages to try and get a response. So this would be probably a little bit angry. Where are you? Why aren't you answering me? Maybe a little bit aggressive. So we see that increase in responding, and then eventually we'll see a drop off in the responding until they stop texting. So we see that extinction burst, and then we see a drop off in responding. And so this is an example using text messaging, but this could be pretty much anything. Mostly we've been looking at sort of rats pressing levers, but this could be pigeons in boxes. This could be whatever kind of behavior we can frame as an operant conditioning task. Next, I wanted to introduce just a couple of ideas here, because we've looked at extinction now as it applied to our classical conditioning and then operant conditioning, but we're also going to move into the ideas of generalization and discrimination, because those are the same with our operant conditioning as they were with classical conditioning as well. But before that, I wanted to take a brief moment and actually name something that we've been talking about without having given it a proper term. So this name is a discriminative stimulus. So this is any stimulus that signals the availability of reinforcement. So while I've been talking, I may have mentioned the presence of an indicator or a warning light, or specifically a cue light, something that tells us that something is available or something is coming. So usually in an operant setup, we'll have a cue light, so just a red light in the box, and when that light is on, it lets the animal know that if they initiate a trial, if they perform a response, then the reinforcement contingencies will hold. When that light is off, when that light isn't lit, even if they perform their actions, even if they press the lever, they won't receive any kind of reinforcement. So this stimulus allows us to discriminate whether we're going to get our outcome or not when we do our behavior. So it's setting up the conditions that we're operating in. So the animals will learn that when the light is on, if I press the lever, I get food. If the light is off and I press the lever, I don't get food. So we would choose to press the lever only when the light is on, because that's when our contingencies hold for reinforcement. Grab my pen tool here so that we can look at our generalization and discrimination. So we had looked at these graphs before. So when we were talking about generalization, we were looking at different angles of lines along the bottom, and then we were looking at, for classical conditioning, it was sort of amount of responding, so how much salivation were we seeing, or something like that. In order to have this same graph apply for operant conditioning, then this would just be our proportion of responding, or how much responding that we're doing. So we would be looking at how much does a pigeon peck when there's a vertical line versus a slightly diagonal line versus a horizontal line. So we just change what this is labeled as. So instead of how much of our conditional response are we seeing, this would just be how much of our operant response are we seeing. And if we see a broad curve, we would be saying that they're treating these vertical lines, the line that they were trained to peck at, very similar to the slightly diagonal lines. So they are generalizing and responding the same way to a similar stimulus. And then if we made the graph a little bit more intense and pointy, we would say that they're showing discrimination, where they're responding a lot to the vertical lines that they were trained on, but as soon as the angle is slightly different, they show much less responding. So if they're treating them the same, then they're generalizing, and if they are telling the difference between them, they are discriminating between them. So same basic concepts, just applied now to our operant conditioning instead of classical conditioning. And then one more term that you might see used every once in a while, and so we've been talking about reinforcement and punishment, but you might also hear the terms reinforcer and punisher. And these are things that are delivered that provide reinforcement. So a reinforcer would be a stimulus or an event that's delivered after a behavior that ends up increasing the likelihood of that behavior occurring in the future. So we could call food a reinforcer. And specifically, we could call food a primary reinforcer. Kind of like when we were talking about our unconditional stimuli back in classical conditioning, food is something that you don't have to learn is rewarding. Food is good, so it would act as a primary reinforcer. But if there was something where you had to learn that it was good, money is a fantastic example of this. That would be a secondary or a conditional reinforcer, because it's something that you had to learn the value of. So receiving money can still be reinforcing, but only because you have learned that it is valuable and can be redeemed for other kinds of reinforcers. So you could use money to buy food or things that you like. So money is a secondary reinforcer, whereas food and other things that you naturally like without any learning would be a primary reinforcer. And similarly, we can talk about punishers as stimuli or events that follow a behavior and decrease the likelihood of that behavior occurring in the future. So a punisher would just be something that makes you less likely to do the behavior. So something that is punishing. So we can see these terms used pretty much interchangeably with what we've been talking about so far. Next, I want to focus in on some terms, specifically our schedules of reinforcement. So up until this point, we've been talking about a rat pressing a lever and getting food. And the implication is that every time the rat presses the lever, they get food. That would be an example of what we are going to call continuous reinforcement, where every time you make the response, then that response is going to be reinforced. And as I said before, we could frame this in terms of reinforcement and punishment, but most of the time, just for ease of convention, we're going to be talking about positive reinforcement, where we are delivering a reinforcer every time an action is performed. We could frame this for the others, but I'm going to stick with positive reinforcement just for the examples today. So continuous reinforcement, every time they press the lever, they get food. But that's not always the case. We can have different kinds of reinforcement, hence the whole next section, where we can talk about our schedules of reinforcement, things other than continuous. So we might have either partial or intermittent reinforcement, just again, 2 words for the same thing, where not every single response is reinforced. Maybe only every couple of responses, maybe every second response or every 10th response. And we're going to describe what pattern of reinforcement we see for these partial or intermittent schedules of reinforcement. So continuous is when you are reinforced every single time, and then the other ones that we're going to look at fall under this category of intermittent or partial reinforcement. And we have 2 different questions that we need to ask ourselves. The first is it something that is fixed, or is it something that is variable? Fixed just means that the reinforcement occurs after a fixed amount of time or a fixed number of responses have been delivered. So maybe every 10 seconds. After 10 seconds have passed, when you press the lever, you get food. Or maybe every 10th time you press the lever, you get food. Those would both be fixed responses because we know exactly when it's going to be delivered. We have a fixed schedule. It doesn't change. The other one, our variable schedule, is when reinforcement occurs after an average number of responses or an average passage of time. So this is when we introduce variability, hence the name. So if we say on average, you're going to get food every 10 lever presses or so. But we say that it's 10 lever presses plus or minus 4. So you might get food as soon as the 6th time you press the lever, but you might have to wait as long as until the 14th time you press the lever. So there's variability there. And we would describe it in terms of what's the average, and then how much sort of wiggle room do we have around that variable point. So if we talk about every specific number or every specific amount of time that has passed, then this happens, then it's fixed. And if we talk about some kind of variability, if we have introduced sort of a plus or minus, then that's when it's variable. Okay, and we can also describe it in terms of it being ratio or interval. And I've already kind of snuck this concept in because we were talking about after a certain number of lever presses or after a certain amount of time. And that's what ratio and interval are referring to. So ratio is just talking about a certain number of responses or after a certain amount of time. So if we say 1 in 10, so on the 10th lever press, that's sort of like a 10% response. There's a bunch of different ways that you can frame it. But if we're saying it's for sure sort of 1 in 10 or every 10th press, that would be a ratio description. So we're talking about a hard number, a number of presses. Whereas an interval is talking about an interval of time. So a certain amount of time must elapse between our delivery of reinforcement. So maybe it's every 10 seconds. So the first time you press a lever, after that 10 seconds have passed, that's when you would get reinforcement. So when we refer to time, we're talking about interval. When we're talking about numbers, we're talking about ratio. And so we can put these, concepts together, and we can have something that is a fixed interval. So the same requirement each time the reinforcer is delivered. So fixed interval, so we're looking at time. So after every 10 seconds, the first time you press a lever, you get food. That is a fixed interval delivery schedule. We can have a fixed ratio schedule. So that's when it's the same requirement, but we're looking at number of responses. So every 10th response, you get reinforcement, or every 100th response, whatever we decide. So that would be fixed ratio. And then on the bottom, we have our variables. So we have different requirements for each reinforcer. We've introduced that variability. So variable interval would be every 10 seconds plus or minus 5 seconds. So we might have it as soon as 5 seconds after delivery, or we might have to wait for 15 seconds in order to get reinforcement. We don't know for sure. And then variable ratio is that variability, but with number of presses. So instead of time, we would just look at number of times you press the lever. So every 10 presses plus or minus 2 would be a variable ratio. And so each of these different types of reinforcement, these different schedules of reinforcement, will produce different patterns of responding. And these are set up on this slide here. So again, we have our time on our x-axis. So this is just the amount of time passed or the number of trials or whatever we wanted to measure. And then here we're looking at cumulative number of responses. So if we just look at our VR, or variable ratio responding here, we can start seeing some patterns. So each of these tick marks on the side indicates that reinforcement has been delivered. So here we would see that the rat would be pressing the lever very, very quickly. They get reinforcement and they're going to keep pressing the lever quickly, because the faster they press that lever, the faster they get their next reinforcer. And we see that there's a different amount of presses in between each of these tick marks because of that variable quality. So ratio means that it's number of presses, so they're going to press quite a lot. With the variable part, we're going to see that they continually respond because they don't know when the next reward is coming or the next reinforcer is coming. If we move over to our fixed ratio, because it's a ratio response, we still see fairly quick responding because the more lever presses, the faster you get food, but we also see a new pattern here. And this is that after each time this reinforcer has been delivered, after each tick mark, we see sort of a leveling out or a plateau. And so this is showing that there's a period after the rat receives food where they don't press the lever for a while. And that's because with a fixed ratio, you know that after you have received reinforcement, you have to press the lever a certain number of times before you get food again. So you're not really motivated to press the lever right away. You're going to wait for a while. So we have these plateaus, these periods where they don't respond as quickly because they know they just got reinforcement and they don't want to press again because they know that even if they press the lever, they won't get food. So we see that step-like pattern because it's a fixed ratio. And then our next two are looking at intervals. So these are our time intervals. VI, meaning variable time interval. So this would be kind of similar to our variable ratio, except because it's not based necessarily on number of lever presses, because pressing the lever faster doesn't necessarily mean that you're getting the food quicker like it does in the ratio schedules. You're going to see that the slope is a little bit less steep. So we're waiting for time to pass. So the rat can press the lever every once in a while, but it's not the number of lever presses that's driving the reinforcement here. It's the amount of time that has elapsed. So we still see that there's that variable amount of time that passes between each reinforcer being delivered, but the rat isn't necessarily as motivated to press the lever very quickly. But because we have no sort of solid knowledge on when you will or won't be reinforced, we don't see these plateaus, these steps, like we did in our fixed ratio. It's just a straight line. So when they're variable, we see straight lines. And then if we look at our fixed interval here, so after a certain amount of time has passed, they will receive reinforcement, we see that kind of a step-like function like here, but instead of it being a hard sort of straight horizontal cutoff, we see sort of a curve upward. So it looks more like a scallop. And what this is telling us is that as it gets closer to the time when pressing the lever gets them reinforcement, they're going to press the lever more and more until they get that reinforcement. And then they're going to stop pressing it after they've been reinforced because they know they have to wait a certain amount of time before they get it again. And then they'll gradually press it more as they get closer and closer to that time period again. So that's what's producing that scalloped effect. And so you can actually look at each of these and kind of tell them apart. Which type of schedule are we looking at based on those qualities that we've just described in this graph? So it gives us a little bit of information as to what's going on. And so, of course, we can ask, which is the best method to be using? Which one is the most desirable one? And so there are a couple of things we need to consider, because the best can be relative. So continuous reinforcement, being reinforced every single time, is really beneficial if you're looking for rapid learning, because you're getting that pairing of the response and the outcome every single time. So we see really quick learning, a really quick association being formed, But it also comes with some downsides. So the learning is happening because the consequences are easier to perceive, because every time you press the lever, you get the food. But that also means that if you press the lever and don't get food, even one time, that's going to show up as a difference. So the consequence is very easy to perceive, and you notice when the pattern changes. This leads to much more rapid extinction. So if you're on a continuous reinforcement schedule and then all of a sudden you don't get food for pressing that lever, you might go into an extinction burst and then extinction of the behavior very rapidly because it's deviated from a set pattern. If we have our partial or intermittent reinforcement, because it's not a one-to-one pairing, we typically see slower learning because it's not every lever press that gets food. There's sort of a discrepancy between pressing the lever and getting food. So it takes them longer to learn that association, but once they've learned it, that association is a lot more resistant to extinction because we actually have it down here at the bottom. So a continuous reinforcement is that it's delivered every single time. When you have intermittent reinforcement or partial reinforcement, you get food sometimes, but not others. And then it kind of becomes hard to tell, is it intermittent reinforcement and we're just being really unlucky for some presses, or is it actually extinction? And because it's very difficult to tell if you press the lever and didn't get food because you don't always get food when you press the lever, or is it because pressing the lever no longer gets you food? So with partial or intermittent reinforcement, it's a lot harder for extinction to occur. And especially our variable responses, our variable either interval or ratio, are very resistant to extinction because we don't have a set pattern. And in particular, our variable ratio is the most resistant to extinction. So we'll see the most sort of persisting on pressing the lever in that situation. Okay, so that is the end of our operant conditioning, but I wanted to take a moment and give you this diagram here that looks at sort of how do we tell the difference between operant conditioning and Pavlovian conditioning. And I also have a link to a YouTube video here, and this does the same basic thing where it talks about operant versus Pavlovian or classical conditioning, just to help you distinguish between the two, because you will absolutely be asked which one is which. So starting with our first thing up here, we're looking at, okay, what's our controlling stimulus? What's driving this relationship? So if we are looking at a particular behavior in Pavlovian or classical conditioning, the presence of our conditional stimulus is what leads to us having our conditional response. With operant conditioning, our discriminative stimulus, the thing that tells us that if we do a behavior, then certain contingencies will follow, that's what starts that behavior. So what we produce behavior in response to our discriminative stimulus. When we look at our learned behavior in conditioning or classical conditioning or Pavlovian conditioning, this is an involuntary conditional response that's being elicited. So this is a behavior that's occurring without sort of intention. It's not something that we're doing or choosing to do. So salivation, a dog doesn't choose to salivate when they have food. It's something that's going to happen automatically. Whereas for operant conditioning, that learned behavior is something that is evoked, something that is voluntary. So it's not something that's happening without their control. They are making a response. For our important stimulus, for classical conditioning, we're focusing on our unconditional stimulus. So that's the thing that we already knew something about, and we form an association with that existing unconditional stimulus. In operant conditioning, our outcome, whether it's a reinforcer or a punisher, that's what's driving this relationship. What do we get out of doing that behavior? This line here is just looking at, does the behavior change the likelihood of a consequence? So if we're focusing in on what's driving that particular behavior, we've said that in operant conditioning, we're looking at sort of increasing behaviors that lead to good outcomes and decreasing behaviors that lead to bad outcomes. But there's no mention of that. There's no mention of likelihoods of consequences in Pavlovian or classical conditioning. So that's a pretty good indicator if we're talking about likelihoods and consequences that we're talking about operant conditioning. When we look at what we've learned in classical conditioning, we've associated our conditional stimulus with our unconditional stimulus. In operant conditioning, we've established that antecedent behavior consequence line, or our stimulus response outcome trio. So different patterns of learning here. And then at the bottom here, we're asking, can this process add a new response to the repertoire? So in classical conditioning, you're just producing what was previously an unconditional response to a new stimulus. You're not learning anything new. You're just producing the same response in a new situation. But for operant, this is how you can sort of pick up on new behaviors. So you can press levers, you can push buttons, you can peck screens. So we're adding new responses to our repertoire. So these are just some of our key points to help you tell the difference between the two types of conditioning.